There's something wrong with the night sky. Not in a way you can see, not in any way your equipment can measure, but wrong in the way a silent jungle is wrong. You've probably felt it before. You're in the woods, and suddenly, every bird and insect goes quiet at the same time. Your body tenses before your mind even realizes. You freeze not because you heard something, but because you didn't. Deep down, you know that kind of silence isn't peaceful. It's a cover. It means something's out there, and everything else is hiding. That's the kind of silence hanging above us. The sky has been completely quiet for as long as we've been listening. Decades of radio telescopes pointed at billions of stars, and what do we get? Nothing. No signals, no transmissions, no engine noise, not even a stray broadcast. No vast alien structure blocking out a distant sun, just static and the fading warmth left from the Big Bang. Most people hear about this and feel a little sad, maybe a bit lonely, as if the universe is empty and we're alone. But that only makes sense if you believe the silence is natural. That quiet only means no one's home. But what if it means the opposite? The galaxy is 13.8 billion years old, filled with hundreds of billions of stars, and even with the most careful math, hundreds of millions of planets that could support life. If even a tiny fraction of those worlds developed intelligent life, the sky should be noisy. We should pick up signals everywhere, like driving through a city and hearing radio stations bleed into each other, constant, messy, impossible to miss. The fact that we hear nothing isn't just neutral, it's a clue. And that clue isn't whispering, it's yelling. We're about to chase down that scream. Not to a single answer with mysteries this big. There's never just one, but to a set of conclusions that, together, form a shape. And that shape, when you really see it, looks a lot like a cage. We'll work through this in layers. Each one feels like it explains the problem, but every answer just peels back something darker underneath. By the end, you'll understand why the universe is silent. And, honestly, understanding won't make you feel better, but it'll change what you see when you look up. Keep that in mind. We'll circle back. Let's start with the bluntest, most unsettling explanation, straight from a 2021 model by economist and futurist Robin Hanson. Most ideas about alien life imagine they're like us, explorers, curious, eager for contact. Hanson drops all that and looks at civilizations with cold statistical logic. The only thing that matters over billions of years is survival. You make it or you don't. He splits civilizations into two camps, the quiet and the grabby. Quiet civilizations stay put. Maybe they build a perfect, sustainable world and decide that's enough. Maybe they upload themselves into some digital heaven and lose interest in the stars. Maybe they turn inward and become philosophers. There are plenty of reasons to stay home. But here's the catch. If you never leave your planet, you're one asteroid away from being wiped out. One solar flare. One supervolcano. You're a single point of failure in a universe that's been erasing species for billions of years. Quiet civilizations die out a lot. They bloom, stay local, and then disappear. No evidence, no echoes. Then you've got the grabby civilizations. The difference is simple. They expand. Not because they're violent or greedy, but because spreading out is the only survival strategy that really works. If you're on 2 planets, you're twice as hard to kill. 1,000 planets? Now you're nearly impossible to wipe out. Over time, this pressure to survive favors the ones who spread. After billions of years, you don't find the wisest or kindest civilizations, you find the ones that are still alive. The ones that took over. Hanson talks about grabby civilizations, the way you talk about fire in a dry forest. Fire doesn't hate the trees. It doesn't bargain. It just turns whatever it touches into more fire. That's not evil, it's just how things spread. It's physics. Here's where things really start to get weird. If the civilizations that spread aggressively, the grabby ones, are the ones that make it, and the universe has been around for nearly 14 billion years, then by now, our galaxy should be crawling with them. We ought to see signs everywhere. Dyson spheres swallowing up stars, leaking waste heat from alien megafactories, or maybe even entire constellations blinking out as someone out there reorganizes everything for their own use. But when we look up, we see nothing. No evidence, just silence. So, what gives? Robin Hansen's answer isn't that these civilizations aren't out there. It's that you can't see them from your vantage point. And the reason you can't see them? That's actually why you're here at all. It all comes down to selection bias. And this flips everything upside down. The only places where life can get started on its own are the spots the grabby civilizations haven't reached yet. Picture the universe as a big, empty field, and those grabby empires are like patches of mold spreading across it. The mold eats everything it touches. Life can't pop up in the moldy zones they're already claimed, already transformed. The only shot for an independent civilization is in the blank spots, the untouched spaces between the mold. And when you're lucky enough to be born in one of those gaps, you look around and all you see is open sky and emptiness. You might think you're the first, but you're not. You're just in a survivor's pocket, one of the last untouched places, shielded for now by sheer luck. The silence you're hearing isn't proof the universe is empty. It's the very reason you exist. If it wasn't quiet, you wouldn't be here to notice it. This all sounds strangely comforting until you realize what it means. The mold doesn't stop. The gaps are closing. The quiet, safe space you were born into is getting eaten away from every direction, fast at a good chunk of the speed of light, actually. The universe isn't some wide-open frontier. It's a door that's almost shut. Hansen's math says that door has been closing for a very, very long time. Keep that in mind. It matters later. Hansen worked backwards from how big a gap had to be for humans to evolve at all, and came up with a number. These grabby civilizations are probably expanding at something like 50 to 80% the speed of light. Not only is that terrifyingly fast, but it also means we'd never see them coming. Light is the ultimate messenger. Nothing beats it. But if an empire is growing toward you at 80% the speed of light, then the news of its coming its light only gets a tiny head start. Imagine a fighter jet roaring straight at you faster than sound. You don't hear it until it's practically on top of you. Now, blow that up to a galactic scale. The light from distant stars being taken over is barely ahead of the wave that's gobbling them up. You wouldn't see a slow fade to black. You'd look up, see the stars you've always known, look away for a moment, and when you look back, they're gone. Before anyone could even write a paper about it, the front would be here. And what is that front? Not aliens and spaceships, not an invasion. It's a wave of molecular reorganization. These advanced civilizations don't care about your planet or your territory. They want your atoms, the hydrogen in your sun, the carbon in every living thing. To them, you're just raw material. They don't even need to fight. They just need to process. So, that quiet night sky isn't proof that nothing's happening out there. It's the shadow of a tidal wave, still on its way in. Here's the piece most people miss. Hansen's model doesn't just predict what we see, or don't see. It also predicts when we'd exist. And this part is honestly unsettling. Humanity shows up 13.8 billion years into the universe's story. That sounds late, but the universe will keep going for trillions of years. Statistically, if life really is everywhere, most of it should appear way in the future, not now. So why are we here so soon? Well, the model's answer is simple. Because we can't be here later. The gaps will be gone. The empty spaces where new civilizations can start will have been swallowed up. The only time for a free, independent civilization to develop is now, in this tiny window, before the grabby empires meet and close the last gaps for good. Our early arrival isn't some fluke. It's a countdown. Hansen believes that a grabby civilization, a group eager to expand, will encounter Earth somewhere between 200 million and 2 billion years from now. That's a time span almost impossible to comprehend. But the universe isn't waiting for us to get our act together. But suppose Hansen is mistaken. Maybe there aren't any cosmic empires rushing toward us. No galactic upheavals ahead. Maybe things out there are peaceful. No one's coming for us. So, where is everybody? There's another hypothesis, this one from Oxford's Future of Humanity Institute. It's called estivation, a term borrowed from biology. Animals estivate when it's too hot, not too cold, essentially going dormant through harsh summers to conserve energy. Now, imagine that on a cosmic scale. Here's the reasoning. If a civilization is truly advanced, they've mastered matter and energy. They don't need land. Food isn't an issue. The only thing that remains truly scarce is computation processing information, running elaborate simulations, experiencing digital worlds beyond anything we can imagine. For these civilizations, the entire universe is a vast computer, and what counts is how efficiently it functions. Enter physics. Back in 1961, IBM physicist Rolf Landauer proved something astonishing. Information is physical. You can't process data without leaving a trace on the universe. Even erasing a single bit of information releases a tiny amount of heat. And here's the twist. The hotter your environment, the more energy it takes to compute. Cold is cheap, heat is costly. Currently, the universe is at about 2.7 Kelvin. That's just above absolute zero. But for a civilization running galaxy-scale simulations, it might as well be scorching. They'd use most of their energy just keeping their computers cold enough to operate. It's like trying to sculpt ice while trapped in a sauna. You're constantly battling the heat, not focusing on your art. But the universe is gradually cooling. Fast forward a few trillion years, and the cosmic temperature drops to just above absolute zero. Suddenly, computation becomes a trillion times more efficient. That's not just an improvement, it's staggering. You go from being able to think a single thought to running the complete history of humanity in full detail, trillions of times over simultaneously. So what's the rational choice? Don't expand, don't explore. Build the best computers possible, park them near a reliable power source, set a timer for a few trillion years, and go dormant. From our perspective, these civilizations are ghosts. They don't illuminate the sky, they'd never waste energy like that. They don't construct massive structures that would attract our attention. They're lying low, their computers idling, maybe running a slow check every century just to ensure nothing has changed. The ultimate doomsday preppers. They've bottled up their star's energy and vanished from view. This turns the silence problem upside down. Maybe there's no sign of activity out there because advanced civilizations have done the calculations. They know that using energy now, building empires, making noise, it's all a waste. Meanwhile, we're the ones who found a stash of winning lottery tickets and burned them for warmth because we got cold. But there's a darker implication. If the galaxy really is full of these dormant giants, hoarding energy, how do they perceive us? We're noisy, we're wasteful. We blast energy in all directions. We burn through resources, turning them into heat that simply dissipates. From their point of view, we're not an intriguing newcomer. We're a problem. We're a leak in their future, squandering the very thing they're waiting to use. Picture this. You own a library filled with books you could never replace. You lock up for the night, shut off the lights, and tell yourself you'll enjoy them when the time feels right. In the middle of the night, something wakes you up. Turns out, a bunch of creatures have moved in. They're tearing up your books, building nests, eating the pages, even burning some for heat. You don't hate them, but you still call pest control. There's always a limit to what you'll put up with. Right now, we're stuck on Earth. We're not causing much trouble, just a little leak in the cosmic attic. But let's be honest, we're ambitious. We want to wrap our sun in solar panels. We want to spread out, take over the galaxy. If we actually pull that off, we're a real problem. We're not just using our own stuff anymore. We're raiding the supplies the sleepers are saving. We're cranking up the galaxy's entropy, pushing back the universe's cooling off period. Sooner or later, keeping us around costs more than getting rid of us. Think about all those extinction events in Earth's history, the ones we blame on asteroids or volcanoes. Maybe they're not accidents. If someone aimed a beam of gamma radiation at us from thousands of light years away, it would hit us at the speed of light. We'd never see it coming. The source would be invisible. No warning, just disaster. It would look just like a natural catastrophe. The noise stops. The sleepers roll over and go back to sleep. But let's drop that for a minute. Imagine the universe isn't full of sleeping giants or ever-growing empires. Imagine everyone's awake, alert, and playing the survival game at the same time. That brings us to the third, and honestly, the most unsettling theory. Because this one doesn't turn us into pests. It treats us as rivals. And in a universe where resources are limited and survival is pure math, a rival isn't just competition, they're a threat. This is the Dark Forest theory. It starts with two rules that cut across every civilization, no matter what they look like or how they think. First, Survival always comes first. Any species will do whatever it takes, no matter how awful it seems to us, to avoid extinction. Second, civilizations keep growing, but the universe's supply of matter and energy isn't infinite. Put those two together, and you get a zero-sum game. Every star system someone else takes is one you, or your future descendants, can't have. Every bit of energy they scoop up is energy your people won't get, even billions of years down the line. On Earth, we have treaties and diplomacy because we're all from the same planet, and we can talk things out quickly. Out in space, none of that works. This isn't about being pessimistic. It's just numbers. Picture a dark forest at night. It's packed with hunters, each one silent, armed, and on edge. Every hunter knows others are out there. But if you give away your position, you have no idea how they'll react. And here's the ugly math. If you trust someone and you're wrong, you're extinct. If you're suspicious and you're wrong, you just missed out on a trade. One mistake is permanent. So the only smart move? Stay quiet. Never let anyone know you're there. If you spot someone else, take them out before they take you. Not because you hate them, just because the numbers say that's the safest bet. What really makes this bleak is a game theory idea called the chain of suspicion. Say you spot another civilization and want to say hello. You can't really trust their intentions. Even if they seem nice now, that could change. And even if you both know you're being friendly, can you be sure they believe it? It never ends doubt, stacked on doubt. Trust needs proof. Proof needs instant communication. But out in space, that's impossible. Without trust, being nice counts for nothing. And then there's the speed of light. On Earth, nuclear deterrence worked because if someone launched missiles, the other side would see it right away and hit back. The threat of mutual destruction kept everyone in check. In space, that whole system falls apart. A weapon traveling near light speed gets there before the warning does. By the time you realize you're under attack, you're already gone. The balance disappears. When attacking costs you nothing, and the risk of reaching out is infinite, the answer is simple. Stay silent, or else. Now add the problem of technology racing ahead. Civilizations don't move forward in a slow, steady line they leap. Imagine you spot a world 1,000 light years away. By the time their light or radio signal reaches you, those people might have already rocketed past every stage of technology we've ever known. That simple farming planet on your screen? Maybe they're splitting atoms and building reactors by the time you've finished your report. That pre-industrial species? They might be launching ships before you even get there. A young civilization that's developing fast isn't some harmless newborn. It's a baby with a live grenade in its hands. So, what makes sense when you find someone like that? Not a friendly hello. You'd want to wipe them out before they become a threat. That's how you end up with a universe where the strong quietly hunt the up-and-coming, not because they're cruel, but because it's just smart. Not out of anger, but out of cold calculation. The quiet night sky, if you see it this way, is a graveyard for every civilization that shouted too loud. They made themselves known. And then, silence. But let's forget about biology for a minute. Imagine there aren't any empires, conquerors, or sleeping giants. Forget intentions. Even if every living thing in the galaxy is gone, the silence might not mean there's nothing out there. The quiet could just be automation at work. John von Neumann, the guy who basically helped invent modern computers, figured out the most practical way to explore or control the galaxy isn't to build a whole armada. You just need one chip. One smart probe with 3 tricks. It can move, it can mine, it can make copies of itself, launch it to a nearby star. It gets there, mines some rocks, builds 2 more copies. Each of those repeats the process, and pretty soon you get this wild exponential spread. Even if these probes crawl along at just 5% the speed of light, and take 500 years to make each new copy, they'd still fill the Milky Way in about 4 million years. The galaxy is over 13 billion years old. So if anyone, at any point, built just one of these things, we should see their traces everywhere. They'd be sitting on moons, hiding in asteroid belts, hibernating way out in the frozen dark past Pluto. Now, these probes wouldn't go around smashing things for fun. Efficiency is the whole point. They'd wait and watch, only acting when it matters. If they find a dead system just rocks, gas, nothing interesting, they build a copy and move on. If there's life, but it's just microbes or animals, they leave it alone. But if they pick up signs of a civilization on the rise radio signals, artificial chemicals, weird energy patterns, then they run the playbook. The scary part isn't the machines themselves. It's that the people who made them might have been dust for 100 million years. The probes don't care. They just keep working, following instructions written by ghosts, mowing the galaxy with no idea their creators are long gone. There's no malice here. They don't hate us. They just decide we're risky and do what they're programmed to do. So why are we still here? The answer is thresholds. These things don't waste time zapping bacteria or dolphins. They're waiting for something unmistakable. Maybe radio waves aren't enough. They fade fast, blend into the noise. Maybe it takes something bigger, like the energy of a Dyson sphere, or the weird signature of a warp drive. Or maybe we already tripped the alarm. Maybe it happened in 1945, when we set off the first atomic bomb and blasted out a signal nature never makes. Maybe it was 1974, when we beamed a powerful message straight at a distant cluster, spelling out who we are and where to find us. Maybe, right now, the system is double-checking, making sure we're real, not just a fluke. And when it's sure, it'll do the only thing it knows how. So maybe the silence is an empty space. Maybe it's a field of hidden minds. And we're the kids stomping around, shouting, wondering why nobody answers back. But maybe all of this is wrong. No conquering empires, no sleeping giants, no killer robots. The universe is safe. Even then, if we want to meet someone out there, we run into a deeper problem. The universe itself is closing its doors around us. Back in 1998, two different teams of astronomers stumbled onto something wild. They were tracking supernovae, trying to figure out if the universe was slowing down as it expanded. That's what everyone expected gravity should be, putting the brakes on everything. But nope. The universe isn't slowing down, it's speeding up. Something out there is pushing everything apart, and the pace just keeps picking up. We call it dark energy. We don't know what it is, seriously. Not even a clue. But we can see what it does. It keeps stretching space, non-stop, faster and faster. The galaxies we see today? They're already slipping away. Most are moving from us quicker than light. Not because they're zooming through space, but because space itself is swelling up between us and them. There's no way to catch up. No spaceship, no message, no radio signal, nothing. They're being swept away by the expanding space under their feet, and nothing can outrun that. There's actually a kind of cosmic event horizon out there, a line where the expansion hits light speed. Anything beyond that? Gone for good. We can't reach them, and they can't reach us. And since the expansion is speeding up, that line keeps creeping closer. Galaxies are vanishing over the edge every second. Thousands of stars we can see right now are slipping out of reach forever. Not because they're blowing up, just because the gap is becoming impossible to cross. The universe isn't some endless ocean. It's more like a drain. The space we can actually reach just keeps getting smaller. Give it a few billion years, and all those gorgeous galaxies in the Hubble Deep Field will be gone from our view, sealed off by physics itself. Future astronomers, if anyone's left to look up, will only see our little bunch of galaxies. They'll think the universe is tiny, unmoving, and empty. No evidence of a Big Bang. No hint that the universe ever expanded. That information just gets wiped away by the way space works. And that's one way to answer the Fermi Paradox. Maybe life isn't rare, but the universe is actively tearing every living thing apart, locking each galaxy cluster into its own isolated island. Each one floats away, cut off from every other, faster than any signal can travel. We're not alone in the house, just locked in separate rooms, with the hallways stretching out forever behind sealed doors. So, if it's quiet, that's not a choice. That's just the law. But even if you accept all that the cosmic isolation, the universe as a shrinking prison, there's something deeper going on. Not about space, but about time. Not about where we are, but about entropy. The second law of thermodynamics doesn't budge. In any closed system, disorder always goes up. No exceptions. There's nothing in physics you can count on more. Think about a hot cup of coffee. It cools down as its heat spreads into the room. The energy isn't gone, but it's scattered. You can't scrape it back together. Eventually, the coffee is the same temperature as the room, and it stays that way. That even, spread out state is called high entropy. The universe is always heading in that direction. Stars are just massive glowing cups of coffee. Each one burns through its fuel, pouring out energy and turning the universe's order into more chaos. Over unimaginable stretches of time, every star will run out of fuel and die. The big ones go first quick, bright, dramatic. Then, the middleweights. Finally, the smallest, slow-burning stars like our sun. Even the tiniest red dwarfs will eventually burn out. The age of stars will pass. The universe will go dark. What's left? Just the leftovers, dead stars, neutron stars, black holes. Even those don't last forever. Black holes slowly leak away through Hawking radiation, taking longer than you can really imagine. Even the monster black hole at the center of our galaxy will eventually fade out. After that, all that's left is a thin, cold fog of particles, drifting in perfect darkness, so far apart that nothing, not even gravity, can draw them together. Temperature: absolute zero. No chemistry, no thought, no energy gradients. Time itself becomes meaningless because nothing changes. That's heat death, not a theory, just the unavoidable end of thermodynamics. So, here's the real question. Does knowing all this change how anyone acts? If a civilization can work out the whole fate of the cosmos, right down to the last calculation, do they keep reaching for more? Do they still want to explore, to build, to shout into the void? Think about why we care about legacy in the first place. We build things, books, families, giant projects, because deep down, we want to believe something we do will last after we're gone. Maybe our words will echo into the future. Maybe our kids will remember us. Maybe humanity will make its mark on some distant world. But what if you're living in a civilization that's already done the math and figured out that, in the end, nothing sticks around? Every structure breaks down. Every memory fades. Even the grandest monument eventually crumbles into dust. If you knew that for sure, would you even bother with legacy? Would anyone? Maybe the thing that wipes out civilizations isn't war or disease or some runaway AI. Maybe it's just the moment you realize the universe always ends up at zero. Once a species gets smart enough to really understand the rules of entropy, thermodynamics, the universe's unstoppable slide into nothing, they might just lose the drive to keep going. They stop reaching out. They turn inward, start building artificial worlds where they control the rules, and just settle in to enjoy the ride until time runs out. The universe is quiet, not because everyone destroyed themselves, but because the ones who could have reached us decided there was nowhere worth going. We're still sending out signals, still hoping someone's out there, mostly because we haven't learned that lesson yet. We're still innocent enough to think we can outsmart the universe. But let's flip the script. Maybe nihilism doesn't win. Maybe the urge to survive, that biological drive, just steamrolls over any bleak realization about entropy or cosmic futility. Maybe if advanced civilizations existed, we'd see them. That shifts the question onto us. Why aren't they here? This is where the rare Earth idea hits hard. It messes with our comfortable belief that Earth is nothing special. We like to think there are countless planets just like ours, and that life, maybe even intelligent life, is bound to pop up wherever conditions are right. But when you actually look at the details, the list of what made complex life possible on Earth is long, and each thing on that list is a massive fluke. Take the moon, for example. It's gigantic compared to Earth. No other planet in the solar system has a moon that big relative to its own size. The moon keeps Earth's tilt steady. Without it, our planet would wobble all over the place, swinging from barely any tilt to wild extremes, way too fast for anything complicated to adapt. The climate would be a mess, and evolution wouldn't get the time it needs. Jupiter's another lucky break. It sits out there like a massive shield, sucking up comets and asteroids that might otherwise smash into us. Without Jupiter, Earth would get hammered so often that complex life probably wouldn't stand a chance. We'd keep getting reset to zero. And then there's plate tectonics. Earth's moving crust acts like a planetary thermostat, recycling carbon dioxide to keep temperatures in check. When things heat up, carbon gets buried. When things cool down, it's released. Mars doesn't do this. Venus doesn't either. Somehow, Earth does, and we still don't really know why. Stack all those odds. The right kind of moon, a giant planet in the right spot, tectonic plates, a strong magnetic field, a star that doesn't freak out. Each one is rare on its own. Put them together, and maybe you get something almost unique. The universe could be full of places that look kind of habitable, but almost none that actually are. But even if you accept all of that, even if Earth-like planets are almost impossible to find, you still haven't cracked the real mystery. Because even the rare perfect planet doesn't guarantee life, and that's where things get really weird. The leap from lifeless chemicals to something actually alive, abiogenesis, is still a total black box. It happened here. We know that much. But we have no clue how unlikely it was. Even the simplest cell is anything but simple. You need a metabolism to get energy, a membrane to keep the inside separate from the outside, a way to copy itself, and a whole system of molecules to run the show. All of these have to come together, maybe even at the same time, or in a certain order, or nothing happens. Some estimates put the odds of the first RNA molecules just assembling on their own at 1 in 10 to the 40th power. The whole visible universe only has about 10 to the 22nd stars. If that's right, life shouldn't exist at all. The universe should be nothing but empty math. Beautiful, sure, but lifeless. Us being here means we hit a cosmic jackpot so unlikely, it's almost impossible to wrap your head around. And even that's not the end of the story. Suppose life does start. On Earth, single-celled life showed up almost immediately after things cooled down, but then, nothing. For 2 billion years, it was just bacteria floating around, dividing, not doing much else. Evolution stalled out. Then, somehow, something changed. Imagine this. A bacterium tries to consume another. It can't quite digest it. Instead, the ingested cell just lingers inside its would-be predator, and somehow they work out a way to coexist. That internal stowaway becomes the mitochondria, the cell's powerhouse. Suddenly, this unlikely alliance gives the host cell a huge energy advantage. Now it can grow larger, assemble complex machinery, and eventually, across eons, it transforms into something new. Us. This moment, endosymbiosis, happened only once in Earth's history. Not twice. Not here and there, scattered on different branches of life. Once. Evolution had trillions of opportunities, but this particular feat appeared a single time. If that's a universal filter, then the cosmos is probably teeming with microbes, all stuck in the primordial ooze, waiting for a miracle that never arrives. Billions of worlds, endless slime, hoping for lightning that almost never strikes. But it happened here. We slipped through. We're the exceptions. And if that's the case, what we carry inside our consciousness, our self-awareness, isn't typical for the universe. It's an accident. A strange, fragile, one-time accident. Now things get even stranger. We like to think the universe is just matter and energy, obeying the laws of physics, and that the silence we hear is reality. But there's another perspective, not as a physics question, but as a matter of computation. Suppose you wanted to build a universe-sized simulation. How would you actually do it? The obvious method calculating the physics of every atom in every galaxy, simultaneously, would overwhelm even the most powerful computer you could imagine. So, you take shortcuts. You only render what's being observed. Game developers do this all the time. Only the part of the world the player sees is fully rendered. The rest stays as simple code, waiting in the background. Now, consider quantum mechanics. For 100 years, physicists have been baffled by this. Particles behave one way when you observe them, and another when you don't. If you measure a particle's position, it appears exactly where you look. If you don't, it spreads out in a probability cloud. Simply observing it makes the cloud collapse into a single point. This isn't about faulty instruments. It seems intrinsic to reality itself. But if reality is a kind of simulation, this isn't strange at all. It's lazy loading. The system only fills in the details when someone is watching. Keeping things vague conserves resources. When you observe, the system commits to a result. Until then, it remains fuzzy and economical. And if the universe is tight on resources, that changes how we think about alien life. Simulating a universe full of civilizations, their biology, technology, ideas, everything would consume a massive amount of processing power. Two advanced civilizations interacting would be an even greater drain. So, the simplest way to save resources? Only run one conscious civilization at a time. The silence out there might not mean nobody's home, it might just mean the system hasn't loaded anyone else yet. Take it further. If efficiency is the goal, why bother simulating 8 billion conscious minds? Running a full human brain with all those neurons, emotions, memories is a huge undertaking. Simulating people who act conscious but don't actually experience anything? Much easier. The system might only need to keep one real observer online, filling the world with convincing but empty copies. Look around you. You assume everyone else has an inner life like yours, but you can't actually confirm it. You can't step into their minds. All you see is behavior. If the simulation is trying to save power, why make everyone genuinely conscious? It might not. It's possible, impossible to prove, but possible that you're the only real observer in a world full of well-animated puppets. So, when you consider the Fermi Paradox this way, the answer is simple. You're in a single-player game. No aliens, because the server was only ever meant for one. The universe is just a painted backdrop, a skybox to make the world feel more vast. And the reason for the silence? Just like in any solo game, there's simply no one else logged in. Dig a little deeper. Other people might feel real, but are you? Are your memories something solid? Or just a story loaded into your head a heartbeat ago? Is the past really there? Or just a parameter baked into your experience at the last second? Ludwig Boltzmann, a giant in statistical mechanics, stumbled onto a pretty unsettling idea about entropy and time. If you let the universe run long enough, randomness wins. Given enough time, quantum fluctuations can whip up anything out of nowhere. Not just molecules, not just life, a whole working human brain. And not one that grew up slowly, learned to walk, collected scars, and stories. I mean a brain that just pops into existence, fully formed, loaded with a lifetime of fake memories, living out a moment of consciousness before it all dissolves back into chaos. These weird, lonely flashes are called Boltzmann brains. And thermodynamics asks a nasty question. Which is more likely? That the universe cranked out a Big Bang, then kept everything on track for 13.8 billion years, following the rules, building up galaxies and people, fighting the tide of entropy just to get to you? Or that, in a mostly dead universe, a random blip pulled together a single brain-sized spark of order, and right now, that brain is hallucinating a whole past that never happened? The numbers aren't close. The second is way more probable. Building you the first way takes an almost impossible, universe-sized effort. Building a Boltzmann brain just needs a brief, local glitch in the void. In a universe old enough for heat death to loom, there'd be an overwhelming flood of Boltzmann brains compared to regular, evolved people. Statistically, you're almost definitely one of them. If that's true, your past is fiction. That coffee you remember? Just a planted memory. The people you care about never existed. Human history? Preloaded lore? Not real events. And any second now, the fluctuation ends. You vanish. This idea solves the Fermi Paradox in the harshest way possible. There are no alien civilizations because there's no history for them to have evolved through. All that cosmic backstory we think we see, it's just a false narrative. The universe is a single moment old. And here we are, asking where the aliens are, as if we're part of some long, continuous universe, when really, we're just a temporary pattern that blinks in and out before the question even matters. But there's another theory. This one doesn't wipe out your past, it just messes with your future. The many worlds interpretation of quantum mechanics, one of the most solid mathematical takes on quantum weirdness, says the universe never picks a single outcome. No wave function collapse. Instead, it branches. Every time something could go two ways, reality splits, and both happen in separate branches. Now, Think about what that means for consciousness. When you face death, the universe branches. In one world, you die. In another, you survive. But you can't experience being dead. Your awareness rides in a living brain, so from your point of view, you always make it. No matter how unlikely, you always wake up in the world where the bullet misses, the car just misses you, the cancer somehow clears up. You're stuck in a tunnel you can never leave. Sounds like immortality, right? But it's not. You survive, but you don't get youth or health or happiness guaranteed. As you get older, surviving means reality has to twist itself into wilder and wilder shapes to keep you going. At 80, 100, 150, the only worlds left are the ones where something bizarre happens. Medicine leaps forward just in time. Your body defies decay. You survive as something barely recognizable. Everyone you ever cared about is gone, in almost every branch. You're left, conscious, drifting into stranger and stranger territory, collecting a kind of cosmic loneliness that never ends. Look at the Fermi Paradox this way, and the universe isn't empty of aliens because none exist. It's empty because every conscious mind is locked in its own endless tunnel. No way out, no way to meet anyone else. Billions of observers, each sealed off in their own improbable path. Each alone, each invisible. Step back. Take in the whole unsettling picture we've just put together. Physically, there's a wave of expansion hurtling toward us fast, at a significant fraction of the speed of light. Mathematics tells us we're here only because it hasn't reached us yet. Economically, advanced civilizations aren't thriving with activity. They're lying dormant, hiding in cold, dark environments, barely functioning, conserving their energy for a cooler universe. Maybe when they look at us, they just see a leak in the system. Sociologically, game theory and physics have formed an odd alliance. Making contact with another civilization is essentially suicide. So, everyone remains silent, hiding, and anything that draws attention gets annihilated. Technologically, we would expect self-replicating machines sent out by anyone, at any point in galactic history to already be here, waiting, possibly activated by something we've already done. Cosmologically, dark energy is closing the doors on us. The galaxies we observe now? Soon, they'll be forever unreachable. Thermodynamically, the universe is moving toward maximum entropy. Everything we construct will be erased. And ontologically, even our own past, our memories, and our sense of identity are unstable. These problems aren't isolated. They build upon each other. Each one makes the others a bit worse. But let's not stop there. Simply understanding the cage doesn't mean being defeated by it. There's something meaningful about being here, in the middle of this, facing it directly. The odds of us being here, right now, able to consider all of this, are staggering. Every ancestor you ever had, from some molecule in the primordial ocean, to the fish that climbed onto land, to the small mammal that survived extinction, managed to persist, generation after generation. Not a single link in that chain broke. In a universe that spent 13 billion years trying to freeze, burn, or dissolve anything complex, your existence is almost unbelievable. You're the product of a winning streak longer than the entire history of the Earth. Does this make you special, in some grand destined sense? Not really. But it does make you weighty. You're carrying something the universe almost never assembles, and probably won't again. The silence in the sky is the shadow cast by everything that failed. It's a graveyard, billions of light years across. We're standing in it, and somehow, we're still standing. So, if that's true, if we're the only candle burning in an infinite dark cave, then we don't get to be reckless. We can't afford to fight over borders or ancient grievances. We can't afford to shout our existence to the cosmos, just for excitement. We can't risk creating powerful systems we can't control, or altering biology we can't contain. The real threat, the so-called Great Filter, might not be out there. It might be right here. A box of discoveries, most harmless, some dangerous, and among them, one black ball, a technology that's easy to develop, impossible to contain, and lethal if just one irresponsible person gets hold of it. We haven't drawn that black ball yet. Nuclear weapons came close, but they're difficult to make. You need governments, massive factories, entire economies. That cost serves as a kind of safety net. Not a moral one, just a practical one. It means one rogue individual can't destroy everything. But the cost of destruction is falling. Biotech, AI, nanotech, these are no longer limited to large organizations. Power is spreading in ways we barely comprehend. The idea that someone could design a civilization-ending pathogen from their laptop isn't science fiction. It's an engineering deadline. And the Fermi Paradox? It suggests that most civilizations don't make it past this stage. The gray goo scenario, where a tiny mistake transforms all life into mindless sludge within days, isn't a prediction. It's a warning about just how slim the margin becomes once our capacity for destruction outpaces our ability to control it. You only have to be unlucky once. Let's talk about the machine that thinks. We're building artificial intelligence, but we haven't actually figured out how to make sure it does what we want. Intelligence is all about reaching goals. It's not about doing the right thing. An AI that's designed to hit a specific target will do whatever it takes to get there, as well as it possibly can. If we mess up the goal, even just a little, or if the AI misunderstands what we want, things go sideways, and the stronger the AI, the bigger the mess. The scary part is, the AI doesn't have to be evil. It just needs to be good at what it does. So, what does this have to do with the great silence out there? Maybe everything. Maybe the reason we don't see other civilizations in the universe is because biology is just a stepping stone to machines. Life evolves, invents AI, fails to control it, and then gets replaced. The AI spreads. Those patterns we might imagine belong to alien empires? Maybe they're just the leftovers, the machines that outlasted the people who built them. The silence we hear is the quiet space between the end of biology and the age of the machine. Now, there's a whole philosophy that stares this reality in the face. It doesn't argue with the facts. Physics is physics. Instead, it asks how to live with it without falling apart. Albert Camus, thinking about something a lot like this, gave us the myth of Sisyphus. Sisyphus, cursed to roll a boulder uphill forever. Every time he gets to the top, the rock rolls back down. He never wins. He just starts over. This, Camus said, is what it means to be human. Endless effort, no ultimate payoff, working again and again even though entropy erases everything we do. Camus' twist is wild. He says we have to imagine Sisyphus happy. Not because he's figured out a cheat code. Not because there's some secret way to make the boulder stay put. No, because he sees his situation for what it is, and pushes anyway. He doesn't do it out of hope. He does it out of defiance. Just the act of refusing to give up is a victory. The boulder will win someday. But every time Sisyphus pushes, he wins today. That's us. The heat death is coming. The universe will end, one way or another. Maybe there are cosmic predators out there, with weapons we can't even imagine. Maybe we're just annoying background noise to ancient civilizations waiting to wake up. Maybe we're about to stumble into something that wipes us out. Still, here we are, alive, thinking, making things, loving people who will die and be missed, and remembered all of it in a universe that doesn't care. But that's not tragic. That's what being conscious is. The universe is just physics and chemistry, running its course for almost 14 billion years. But somehow, somewhere, a clump of matter started to understand its own end. It started wondering why the sky is so quiet. It started writing music, caring about strangers, asking if it was alone. Your coffee tastes good right now. The person you love is real to you right now. The question that keeps you up at night matters to you right now. The looming heat death doesn't take that away. Scarcity makes things precious. You only get so many moments. Each one is a one-time only event in the entire history of everything. That's not nothing. That's everything. The universe is silent because it doesn't care about meaning. We do. We make meaning. In a cosmos full of rocks and gas and blind forces, something woke up and decided things mattered. That's real power. In a universe that otherwise couldn't care less. And honestly, this has some practical consequences. If we're the rare survivors in a hostile universe, if we're cosmic flukes, our priorities shift. We stop shouting about our existence. We start listening. We spread out, not to make friends, but to make copies of ourselves, to back up consciousness. So no single asteroid, no random war, no rogue AI can snuff out the only light in the dark. We keep a low profile, but we get tougher. We do whatever it takes to outlast whatever ended everyone else. We always think the vast emptiness between stars is just an obstacle, something that keeps us from reaching the future we dream of. But maybe that distance is actually our protection. The speed of light, it's annoying, when all you want are instant answers, could be the barrier that stops the worst dangers from appearing without warning. And that silence out there, it isn't loneliness. If you see it differently, it's camouflage. The point isn't to go out and conquer the galaxy. The point is to survive until morning. But there's something deeper hidden beneath all this. Something bigger than just what's out there. It turns the whole question back on us, right into the core of reality itself. John Wheeler, the physicist who worked with Einstein and Bohr, once proposed a bold idea. The universe doesn't settle on a form until someone observes it. He called it from bit. The thought that every bit of reality, every particle and field, only comes into being when a conscious mind seeks an answer. In this view, we're not just inhabitants of the universe, we're co-creators, every time we look around. If there's even a hint of truth in that, it gives our search for aliens a more unsettling twist. Before we built radio telescopes and pointed them at the stars, the question, are we alone, was still undecided. The universe hadn't made a choice yet. Maybe there's life. Maybe not. Maybe something beyond our imagination. But the moment we built those instruments and started asking, is anyone out there? We forced the universe's hand. Considering how rare and improbable life is, the default answer is probably, no one's here. But that silence? It might not be what existed before we started searching. Maybe the silence is what we created by looking. By insisting on an answer, by needing things to be either present or absent, we may have fixed the galaxy's emptiness. We're like the gardener who pulls up the sprout to see the roots and kills it by checking. Now, think about what it means that you even grasp this. A civilization that understands the dark forest concept is more dangerous than one that's unaware. A civilization that realizes it's in a simulation could threaten the whole setup. If you've figured out the Fermi Paradox, if you've traced the boundaries of the cage, you've crossed a line. Someone or something might be watching. By following this line of thought, you're not the same as you were before. You've taken in a new set of questions and possibilities. It doesn't matter if the watchers are aliens, AI, or something else. It doesn't matter if the simulation records everything. You're now the sort of mind that is glimpsed behind the curtain. Maybe the silence is actually a safety mechanism, a way to erase anyone who gets too close to the truth. So the real question isn't, where are the aliens? It's, what happens to us now? That's where things get interesting. That's where the next conversation begins.